Hello, welcome back to one of I think it's the second Fusion stream we're doing. Trying to get back into the streaming. It's so much simpler than the post-production, I tell you, on videos. I've done a few in the last few weeks where it's a whole lot of editing. So we're going to try and keep things much more simple. So we're just going to jump right into it. What I did was I found my old drafting portfolio recently, and it's all over the background here. And what I thought would be interesting was to take these original sort of first year, actually exactly first year college course drafting problems and kind of reverse engineer them using Fusion. So you'll see what I mean here when we get into looking at the portfolio. So here is the portfolio itself. And just get on there. So, of course, there's the title page, right?
Spring of 1989?
Yep.
Oh, Lord.
Only 31 years old. Um, but all the ideas are the same, right? It's all the same concept as it was back then. This was actually in like the basement of one of the buildings at San Antonio College, down where the big computer used to be in the 70s. So, anyway, you get credit for writing your name nicely.
Well, it's awesome.
Then here's the first problem. So these first problems, this was technical, referred to as technical drawing. Most people think of it as just drafting, but drafting is kind of generic. Um, Technical drawing is meant to produce diagrams, blueprints that you can reproduce an object with reliably. And the one of the first things they wanted to teach you was how to look at an object in the three main views, which would be the top view, the can you see where is my mouse? Here, mousy, mousy. You can't see my mouse.
I can
Anyway,
see your finger.
yeah. Unfortunately, I can't quite point all the way. So, in any case, there's the top view, which is in the top left corner here. The front view, which is in the bottom left corner, and kind of in the middle is the right side view. And you can kind of see how those would be the views as if you were looking at each side of the object from a flat plane, the three flat planes, top, front, and side. And so for years, we've been able to produce all sorts of manufactured goods with that style of diagramming. Usually the isometric view or the 3D view isn't really included in old school blueprints. It is in some, it's an auxiliary view, it might be there. But for years we used just these three main views. And with this exercise, what the instructor did was he had an object that was shaped like this. I think it was wood, could have been cardboard, I don't know. Anyway, so he would hold it up and say, look at it from this side and that side and draw a sketch of what you see. Of course, the puppy comes in. So, in any case, I'm kind of going to reverse these first few diagrams. There's this one. This one's kind of like a little H-shaped bracket. I'm not sure what it was supposed to be for. And then this little additional brace bracket, I guess. And this one didn't have the three-dimensional view. It just has the three primary views. So, my thought was, in all of those first four, one, two, three, four, yeah, I think perhaps we will be able to get through these first four objects, recreating them in Fusion so that I can then 3D print them, and then we can go back to what we did originally, which was look at the object and so on. So that was the goal for today, was to get through these first four objects. Now, many of them don't have dimensions on them because we were sketching the object and you didn't necessarily know. But we can assign some arbitrary dimensions. There is one, the little curved brace bracket. That one we first sketched, and then later on we had a dimensioned drawing of it. over here. And so that had all the dimensions that were necessary to actually create the object. So that's our goal. Those first 4 objects recreated in Fusion 3D, a modern tool. There's certainly no need to do text anymore, is there? I'm so glad. My lettering was kind of the worst part of my drafting.
Your lettering is really good, though.
Well, it was really good by my standards. And certainly by my today's standard, which is horrendous. Um, but in any case, let's see. Let's get back to the first one. And we'll jump over to the Fusion tool and actually start recreating this. Here we are over in the tool. And I have a little overlay here of the original drawing so that we can kind of reference it as we need without having to switch back and forth between the shots. So this is pretty much how Fusion comes up when it's first out of the box. Let's see. So one of the best practices is to immediately save your first document. So the first thing you do is save, and you put it in some folder. I have all sorts of project folders. Let's see, what was this one called? Retro Redo. And we'll call it Episode 1. So we're actually going to create all 4 of the objects in the same document. So that's the first step. Name it something, save it, have it already out of the way, and then immediately we're going to create a new component. And this is going to be very useful later when it comes to editing and so forth. So the idea is you would have separate components for each item within an assembly, and then you would assemble those components and duplicate them as needed for a given assembly. Oh, component 1. We'll call it, I don't know, figure 1. Some of these have names. They relate back to the actual textbook. We'll get into that in the next couple episodes. So the first thing you have is a component, and you have an origin. So you have the 3 planes, the bottom plane. So they actually have names here, the front, right, and top views. Just like we used to do on paper, those 3 separate views. These are the 3 planes that create those 3 views for any given object. So let's take a look at our object again. So the way Fusion operates is that you ideally can just sketch the basic outline. So there's my cursor. You can see that, right? Can you see that cursor?
Yes.
All right. So you want to kind of just make this main outline first, looking down from above. And that means that we want to draw our sketch on this top plane. It's actually the bottom in this view, or will be the bottom. There's a couple of reasons why you want to center your object on the origin. It's kind of useful for moving things around. You have a definitive amount of movement in each direction, rather than drawing it somewhere off to the side. So the first thing we want to do, and we're going to try and keep it to mostly just the toolbar buttons and nothing terribly complicated here to begin with. So none of these diagrams are particularly complicated. So I have to remember to click on the tool. See where the mouse is now? All right. So first thing we want to do, create a sketch. We're going to create it here on this top plane. And then we're going to use the cube to look straight at it. Right? Now we could kind of trace what we have in our diagram, but I'm going to see if I can do it from memory. Didn't expect that dialogue there. Let's put them over there. All right. So we're going to start with drawn lines. And it was some sort of box, kind of like this. Went to like there. Went over to there. Lined up with that. So you can see it's given us all sorts of little helpers about how much our angle is for our line, and it's automatically snapping. And all these little T-shaped things you see here are what are called constraints. So basically the constraints say these lines, all we really know about these lines, they're all blue right now, which means we don't know everything we need to know about them. We just know basically how they're laid out, and that each one of them is at a 90-degree angle to the other, basically. And those constraints are what's going to use to keep the shape in shape as we now size it as we need to size it. So I keep going the wrong direction with the mouse, but other than that. So now we have our general outline of our shape here. We're just going to assume, conveniently, that this shortest length right here of the L is going to be one something. In this case, I'm going to do everything in centimeters, simply because that's how everything's set up right at the moment. And centimeter size objects are easier to print than inch size objects. They take less time. So this little length here, I keep again pointing at the wrong space. So this little length here, that little L shape or cutout shape, is going to be our target for a unit of 1, or in this case 1 centimeter. So that's our first dimension. Keep clicking on the wrong screen. So now we take a dimension and we say the distance between here and here is, well, 10 millimeters, which is 1 centimeter. So how convenient. This is actually all set up in millimeters because of the 3D printer. So now, let's say, well, that's 1. If that's 1, looking at this sketch, if this is 1, then maybe the rest of this is 4 times that, from here to there. Because I know the ghost image isn't quite great. Let's move this a little over a bit. Oh, can't move it. Unlock it. So yeah, let's do that. And then, oops, accidentally rotated. There we go. So here, there we can see it all. So now we actually see our 3D object, and I can point to both at the same time. So here's our one little ledge here. We're going to call that 1 unit. So how much is this to here? I'm going to guess that's 4. So again, we're still dimensioning from here to there. Oh, how convenient. It kind of snapped to it, all this. That was totally by accident. I was not at all planning that. But there's a grid, right? There's a grid I'm sitting on here. And so that helps. Now the distance between this segment and this segment and then this big tall segment, they all roughly look equal. Like this is a third. Get back over there, you bad mouse. There we go. So this looks like about a third, and a third, and it's maybe 2 units, 2 of these for each of that. So that would be 2, 4, 6. So 60, right?
Yeah.
Sounds good.
Yeah.
So again, we're still dimensioning. We go from here to here, and it is not 100, it's 60. So that's me, kind of maybe. 60? What am I missing? It looks a little off. Oh no, it's 90, because it would be 3 tens, or 3 this way, 3 that way, 3 more. That would be 90, not 60. Yes, that looks far more like it. So that's kind of looks like the view from above.
That's it.
Right? So that's the kind of view from above, and this is a very simple object. All we have to do now is draw that image up, what they call extrude, up whatever this distance is, which is maybe 2 units for this first thickness. I think it's about right.
I have no idea.
Oh, it's because my mouse ain't in the right screen. This distance here is about 2 of these distance here, roughly speaking. This rectangle here looks
Okay,
like
yeah.
so
And yes.
a 2x1 rectangle. So I got to find a better way of turning that thing on and off. So do 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 do. Uh, so pretty much we're done with the sketch now. Actually, oh no, it's not black. The lines aren't black, so there's a missing dimension somewhere. Can you guess it? There's one thing missing, and it's this
What?
distance between here and here, which is not 25.04 whatever. It's 30, right? There we go. And I think the only thing left, I'm not sure what's left to define. It should turn black once you've defined everything that's necessary. It certainly looks like everything's defined. That's 40, that's 10. These aren't great dimensions. Let's maybe move this guy over here.
How tall is it? Does it say that?
We haven't gotten to the tall part. Let's see. Yes, that would overdimension it. Well, I think the only thing that's left is it's not tied to any spot on the chart on the grid. So, in other words, there's no spot that keeps this from moving around in the diagram. If we drew something else, so anyway, it's sufficient for this time. So let's go ahead and finish the sketch, and then let's look at it from the same kind of angle. Oops. Whee! Sometimes I hate this cube. There we go. That's from the front left. Oop. One more. That's the angle we're looking for. Now you can also press the shift button and the center mouse key and do this kind of thing. But that doesn't show up on the screen. So I'm trying to do everything where you can see what I'm doing. That's the center mouse button for panning around. That's one of my pet peeves of all these 3D programs is this one has a different way of doing it than the 3D printers, and it has a different way of doing it from some of the other tools out there.
Hell, dude.
Yeah.
Everybody wants to differentiate themselves.
I know, right? So now we need to add some thickness to this. So we just click in this area. It clicks what they call the profile, which is this enclosed area with no leaks. It's got a solid line all the way around it. And we can say we want to extrude that roughly 2 units, which is 20. And boom, there we are. That's the base of it, right? Now we just need this tall section in the back. So for the tall section, every time you first, or right after you extrude something from a sketch, it immediately hides the sketch. So you have to unhide the sketch. And did we forget a line in the sketch? We might have forgot a line in the sketch. Yes. Oh, that's because it was here. That's why. So there's another line from the top view that we missed. Nobody called it out, I tell you. And that line goes there, and it is located at 30 over. It says over constrained, but that line wasn't there. So we'll finish the sketch. And so see, we just went back and edited the sketch here in the review. This is the history of all of the changes we're making to the object. So if we need to change the size of this later, we can come back, edit the sketch, and all of the things that we've done after that will follow most of the time. It's always most of the time. So now we need this other section, and I'm going to lean on the left mouse button until this menu comes up, and then select that profile. And now that needs to be how tall? If this is 20, if this is 20, then what is this? Maybe 40? Double that? Sounds about right. Or looks about right, I should say. So let's reselect that profile and extrude it again. And now it's going to try and do a little something here. It's going to think what we want to do now is to cut into this part and not add to it. So if we make this 60, you see it turns red. And that's because it thinks we're going to cut away that part of the previous body. And of course that can be changed from saying I want to join to the previous body. And so there's our shape. Now let's see how close it is. See, what we'll do is we'll rearrange this, zoom down, see if we can't get these guys to line up. I think this is how he actually graded our papers. He had his version of it pre-done on vellum. Oh, apparently it didn't like that. He had his version of it pre-done on this thin vellum that's used for blueprints. And then you can just put them on a light box and see if they're correct. So, my sketch is a little kind of not quite right. But it looks like it's about the correct shape. Yeah, pretty close. Well, we're going to call that one done. All right. Moving on to the others. We will go to the second object. This sort of double H thing. It looks like a little, sort of a double bracket. Right? Similarly not all that difficult. Right?
Yeah.
Now, in the 3D printing world, because it's additive manufacturing, you pretty much create the object and then slice it up, let the software slice it up and print it. If you were going to make something like this out of metal, then you need to take into account the series of steps. So let's save. Now, this is something that is highly encouraged on Fusion, is name what you've done when you save it. Being able to save a little note about what you did differently or what was new helps you be able to go back in time and make changes later. So we'll just call this Fig 1 done. Hide the sketch. And new design. Alright, so this is going to be Figure 2, which is that little H shape. I don't know if it's H shape. Again, these don't have names because they were just things he held up. Later on, we have objects that have these various names, and they line up with the diagrams in the textbook. So, let's see, little H shape. Not particularly difficult, but let's pretend this time that we're making it out of a hunk of metal. Right? What would be the steps we would do to make it out of a hunk of metal? And when we do that, we'll understand why you want to put certain dimensions in versus other dimensions in. Ideally, if you can, like this bottom corner here of the bracket, if you can define all your dimensions from this point, and from all of these dimensions from this plane, then that's a reference that never changes throughout the machining. So pretend that, for example, this is one humongous block of metal. So that's what we're going to do. We're going to start with one humongous block of metal. We're going to assume this distance is 1 unit, and this distance is 2 units, similar to the ones before. And then we'll kind of go from there. Sound like a plan?
Sure.
All right. Let's get drawn an H. So that's our top view. And again, that's pretty much how we're going to play this. So if this is 1 unit here, that's 2 units there. This was previously 60. with it being a third, a third, a third. Seems reasonable enough. So this is going to be 60, and that's 50. That was the same dimension as the previous object. 60 by 50 square. And let's see. I'm twitching around looking for what I need to actually change here. So there's our top view. Put it over here so we can still see it. And we'll just draw off in this corner. So, oh, I had actually said that we were going to save all these in the same object, or the same file. So we'll close out, this really needs to be on a hotkey. So we'll close that out, and we'll go ahead and create a new component. And this is going to be figure 2. And if, in this case, these two components have nothing to do with each other. But one thing that you can do is, hello folks. One thing that you can do is by having this previous object in the background while you're working on your next object, your next component, you can reference it. And so if a size of a lower component changes, the upper component automatically changes. So those are convenient features of parametric CAD, which is what this tool is, that were not around when I was doing this first time, 89. So we'll go ahead and hide figure 1. And we'll go click on the right screen instead, hiding figure 1. This is going to be a continuous thing. There's our diagram. Let's see if I can remember it well enough. Or we'll just leave it up on screen. Go ahead and create a new sketch. It's on the top plane. Take a look at the top plane. I'm going to move the center line over. Now we said we were going to make a rectangle 60 by 50. Since we know the size of that rectangle, we can actually create a rectangle centered off the center point. And it's stupid everything over. Fraggle raggle. Fraggle raggle. Alright. Again, we're going to create a rectangle, but instead of using a corner to corner, we can go from the center. There's our center point. We know we're 50. Oh, I didn't do that quite right, but whatever. I'll just dimension it. 50 by 60. Wasn't that not 60 by 90 was the original dimension? Sorry. 50 by 90. So we have that. We've got this little U shape cut out, right? So let's start back with the lines. I'm out of practice, I tell you. So out of practice. Alright. There we go. Now we've got it all in view. So that little U shape is something along the lines of, oh, we said it was 1 unit. Yeah, we said these were going to be 1 unit, which is 10, which I believe is about like that. And then it goes in a little ways, and it goes down a little ways, and it goes back out. And that's totally in the wrong place, right? Yeah. But now we'll go ahead and dimension it. This thing is 30. That's what we wanted it to be.
Over.
How's that? So you see how these lines are black?
Yeah.
It means it knows everything about the object, and it's fixed.
Yeah.
And now you see these two lines are still blue. We'll go ahead and dimension them there. Definitively say that it's 10. And there we go. That looks not quite the same, does it? I'm going to knock these up to 15 each. just because it looks a little closer to it. Yeah, think so. All right. Now we have this extra line right in the middle here. We don't really have to worry about it because we can essentially ignore it at the moment because we're just not going to select it as part of what we make thick, right? So now we got to make this sort of this shape over here on the left part of the part, which is another 3 quick lines. Let's see, we're going to put this roughly here. We can put this one there, and you can see how Fusion automatically sort of tries to intuit what you're trying to do. That if you're approaching a line at 90 degrees to it, it thinks, oh, well, you want to attach the line at 90 degrees. That doesn't mean you can't change it. In fact, here's a selection to actually rotate, selector for rotation. But what that allows you to do is all of this sort of rough sketch and then do the final dimension after. That's 15. Let's see, this one to that one. Make that 30. And then this one to that one. Cancel. There we go. Look more or less correct. We can sort of declutter it a bit here on the sketch palette. You can say things like, don't show the dimensions, don't show the constraints, kind of clean up the diagram a bit. But otherwise, that looks like the top view diagram, correct? Close enough. It looks a little fat in the middle, but aren't we all? Nah. So.
It's not, though.
Close
it's
enough.
Not.
Close enough. We can finish the sketch out. There we go. And it is this little corner I was looking to... Nope, that was not the little corner I was looking for. This is not the corner you're looking for. This is not the direct... Oh, look at that. How's that convenient? No.
Whoop, whoop, whoop.
So much easier to just use my mouse. That's the one I want. I believe there's some home key for that. I'll have to figure it out. Anyway. So we're back to that view, and now we can do some extrusions, yes?
Yes.
Click that profile, and actually this profile, this profile, this profile, and this profile. And the reason I'm doing that is to, again, assume that we're creating this from a solid block of metal. Correct? So we got to presume some type of height here. If that's 15, this is 20, 60, we'll call it. That'll be, it's like 3 inches tall, by the way, roughly speaking. Not quite, but anyway, 2.5 maybe. So we're going to extrude it as if it were a billet of material. And we're going to extrude it out to a height of, well, we can actually just drag the arrow this time. And the arrow just pops to different distances of convenience. What did we say? 60? There we go. So there's our block of metal. Correct? And as I had shown before, it likes to hide your sketches once you've done something with them. So we'll unhide it.
Rename it?
Yeah, that should be the next one of the things we do next. Yeah, let's do that before we get out of sorts. So that one is just sort of a double click. Oh, figure 2 is correct, yeah. So now if we go ahead and save, we can say started to figure 2. I know it seems a little pedantic to do it here in this case, if that's the right term. Um, but what it allows for is just the idea that you should really save periodically.
Yeah.
With
You can
any
find it with something that you can find.
right, and then in this, I won't get into it this time, but in this back data panel, it has all of the files that you've had in history, the changes you've made to those files. Each save has a name, so you can go find it at a particular stage. I suppose you also have date timestamps, so if you were billing hours, it would all be recorded in there as well. I don't know, I don't get into the billing hours part. Alright, so let's bring our object back into play, or into view. And now you see we have this notch right here, but we also have this this big swath that needs to be taken out, right?
Right.
Now, if you were doing this with a tool, you would want to know how far this distance is so that you could make this cut. And of course, you need to know this distance to how far to make the cut. And then you might make another cut this direction if you were doing it with, say, a bandsaw or any kind of flat saw. So we, in a way, need this side view in order to make this major cut right here. So let's go ahead and create the side view. We're going to create another sketch, but this time, instead of putting it on one of the flat planes of the origin, we're sticking the sketch right on the side of the object. So plop, we're right on the object. We'll go look at it straight view on. And now we're going to draw almost this view. Now, it's going to show hidden lines, or this shows hidden lines because this is the diagram of this object. And we're going to draw it with solid lines so that those are different profiles because we're going to do different things with the different profiles.
Right.
So we really just need this box here defined. So this was 30 across, 30, it was, yeah, 30, 30, 30 for each segment. So first we need, well, let's just sketch it out first rather than worrying about the numbers. We need a big old cut like this. Correct. And then we're going to have a line somewhere in this vicinity. And then we're going to have a line somewhere in this vicinity. Let's start dimensioning. Oh, I accidentally put that line. See, this line shows that it's solid black. And it has these triangles. So I might have accidentally hit the triangle means center point. So I accidentally defined this line as being at the center point between this direction. So now I have to get rid of that constraint if I want to move the line. So you can just click on the actual constraint graphic, delete it. Now it's an undefined line. We want to go from here to there. And that was going to be 20. And we want to go from here to here, and that's not 30 point some strange number, just 30. Where exactly is that line, I wonder? So this distance here. Well, let's see, that's 20. Well, maybe 30. Let's make it 30. Just happy little dimensioning accidents. And then this back one was 30 as well. There we go. There's our side view. Again, let's hide all the dimensions. And we can finish the sketch. So now you see we got a sketch on the bottom and a sketch on the side. Correct? Now let's just, like we're going to just slice this through. So we're going to extrude, and we're going to extrude into the negative here. And we could give it a particular dimension. This will be useful in the next one of the next objects that we do. But in this case, we want it to just go all the way to the back side of the object. Now, if we gave it a specific dimension, like say this, if we drug it through all the way to there, that's 50, and right now that'll work. But if later we go back in and change the original sketch way down here to make it a different distance, this 50, maybe make it 55, then this will be 50 and it won't have completely cut through. So instead of giving a specific distance, you can say do it to the next object, and then you select the object being the plane on the back of the disk. So now if this plane changes as you change the underlying object, this cut stays consistent. Well, that's really just so that you can, it's all about when you have to make changes. That's what this really shines, is when you have to make a change to an object or a diagram. It's really fast, and making a change early on, recording the actions this way allows you to take a change early on and propagate it all the way through with very minimal hurt to the final design. So there's our extrude. In this case, a cut. Bloop. So now our object is, I guess this, you can see the little orbit icon, right? So that's me hitting the shift button and the center mouse button at the same time. So now we're going to lean on the left mouse button, select that profile, extrude up. Again, to object, but this flat part. There we go. And now this next one looks a little bit kind of tricky. We couldn't just, we can't just take this segment. Let's turn her around. If we take this profile and extrude it up the way we have been doing, well, we're going to take away way too much material, right? Now, again, if this were mechanically created, you would draw this outline, this profile, you'd draw it up here, and then extrude downward cutting, and that would simulate cutting out that block. But I want to show you one of the convenient things that they have in here in that extrude tool, is that first off, we define this as being 30, correct? And so with that being at 30, it went and hit our sketch. There's our sketch. So now what we want to do is we want to extrude that profile, but we want to start at this height and then go through the top of it. So it's not too much difficult, just extrude. And instead of the profile plane starting point, we want to offset plane. And then it wants a distance. Let's see, offset. So the distance doesn't have the to object option, it looks like. But in any case, we know it starts at 30. And then the extent will be to object, this top object. And you get a sort of quick preview of what it's about to cut, right? And we'll click OK. There's our magical object.
Oh.
Right?
Yeah.
And then we can actually clear things. I'm going to take it as looking close enough.
It looks pretty close enough.
And then, of course, we can close out whole segments, all the sketches at once, for example, versus individual sketches. And then these are the individual bodies. Now, this is where I actually, because of the 3D printer and being able to find these later, I usually rename the bodies to what it is. And that's because when I export the body to the printer, it's this name that it picks up on automatically. Alright, so that's figure 2. How are we doing on time?
Are 49 minutes into it.
Yeah, getting a little rambunctious? No. I don't know what to do.
Yeah.
Anyway. So let us be done with the figure 2. Figure 1, figure 2 goes away, and create a component called figure 3. We don't really need to see the origin now. It's just convenient when you first start to get a good orientation. But you don't generally need it. Alright, figure 3, moving on. Oh, we almost made that one already. As part of what we were doing on the other one. That's pretty straightforward. It's actually just a total rectangle to begin with from above. Correct, and one cutout shape. So since this is 2 thicknesses that can be separate... Right, so there we go. You see, it's one major outline for this thickness, and then it's this other outline for the rest of the thickness. A couple of holes drilled and one little radius. Now, this is one of the few objects that we later drew using the actual dimensions of the object. So I'm going to actually switch over to that page, and we'll go from that one so that we actually have the dimensions that were mentioned, the dimensions, as it were.
Mentioned dimensions.
Dimensions. Oh, don't mention my dimensions. Can you read those? 2, let's see, 2, 4, 8, 1, 2, 3, radius of 2. Damn it. Sorry.
1, 2, 3.
There we go. Yeah, that's 2, 4,
Want some glasses?
8, 1, 2, 3. Radius 2. 2 drill, 2 holes. 2 drill, 2 holes. That's correct. That looks like 1. That looks like 3. Was that 5 altogether? Might need to actually break out the actual drawing. Yeah, that looks like it. We'll just go with those. Good guess. Anyway. Alright. Alright, let's see. Drawn from below, it's a 4x8 rectangle. Start with a sketch. Sketch from above. Look from the top. Move it around. Alright, 4x8 rectangle. And in our case, that's 40x80, since we're using millimeters instead of centimeters. Again with the center rectangle. Alright, so I kind of screwed up. I didn't mean to do that. Actually, I did mean to do that, but we're going to just escape. Hit the escape button. We get out of doing the center rectangle. And one of the more interesting little features of Fusion is this right-click button. So you see up at the top it says repeat center rectangle, and now shows this cone. So if I want to repeat the last command, if I ever want to repeat the last command, I can just right-click, drag up, and that repeats the last command to do a center rectangle. Same kind of thing, if you can get coordinated enough, you can go to the press pool command or delete something. You can go to the whole command, move or copy command. So this is a pretty interesting interface for if you got enough muscle memory to go straight up the middle and get these at the right angle, undo is, I guess, ostensibly swipe left. I guess this would be. It's kind of a swipe interface.
Oh.
Oh, sketch, finish sketch. Ah, what did I do? Let's see. I just finished sketch. That's what I did. All right, we'll go back into it. All right. So, get our origin back in place. And right click. And of course I can't do that now. So back to the menus. Rectangle, center rectangle. So, managed to make it 40. See if I can do this just by dragging. Okay, it's supposed to be 80. Come on, 80. There's 80. And 40. I know you can't really see it. There's 80 by 40. Except because I didn't actually type in numbers, it doesn't rectify it. I don't know what they call it when it determines that everything's fully defined. So now you got to go back and put in dimensions. You don't technically have to, but if you think you're going to change it later, then you really need to put in dimensions, or force dimensions rather. So that one and that one. Oh, not that one. That one. Accidentally hit escape. There we go. 80. Now, if you say here's a dimension, it suggests one, and then you accept it, well, now you've defined it. You also see these constraints. This is what is a parallel constraint. It says these two lines are parallel to each other. Even if you changed other attributes about them, they're going to try and remain parallel to each other. But now, because these other ones are the perpendicular constraint, these little t's, then it's fully held. I believe this one is the center constraint. I forget all of them. Anyway, they're up here. So you can choose to pick two lines and force them to be parallel. And then if you move one line, the other one moves with it in order to stay parallel. Same kind of thing if you make one line tangent to a circle, and then you start moving the other end of the line around, it'll stay tangent to the circle. Let's do that. Let's do that demo real quick. So we'll have ourselves a circle. We'll give ourselves a line. And we'll say this line and this circle are constrained by a tangent association. There's a little tangent constraint. Now your line is perfectly lined up with the edge of the circle, which is convenient, of course, for various things. But if I then take this end of the line, when I decide to move that line around, it's going to keep that line tangent to the circle, and apparently in the same direction. And since I didn't say how big my circle was, it's saying, okay, I can change the size of the circle. I can change where you move, because you didn't give any other definitions. So if we said something, for example, if we said this circle has a fixed dimension, I'll just give it 30. Now if we take to wanting to move this point, then now the circle is fixed at 30, and the line has to move around it in order to stay tangent to it. So as you can imagine, this helps to easily draw things like brackets, and there's a whole lot of circular things in machinery. So, in any case, a quick demo of the constraint there. So we have all these other constraints. We got our basic square laid out. Now from above we have this little cutout, which is 1 wide and what is this depth? Well, it's the difference between 2 and 4, so 2. So again, we can just roughly sketch in the lines. Wait a second. Yeah, there's the one line. And then the other line. I actually drew that on the center line, which I shouldn't have, because now we've got that constraint in place. But we can delete the constraint, as I said before. So now this is actually, this distance here is, well, let's just put that in the dir pile, since it is 2 by 4 and it is the center. So let's put that in the dir pile and let me hit Control Z a couple of times, and okay, we're back. Because it is supposed to be there in the middle of the object. Now this distance here is only supposed to be 10, so let's finish that dimension. There we go. Now we're ready to start doing some extrudings. Finish the sketch. Orbit around. Bring her down a little. Let's see, the overall height was supposed to be 5. I think that's what this says here, 5. Looks good enough, right? Extrudify. Well, first off, we need the entire thickness to be extruded this one distance. So that's going to be 10. Again, unhide my sketch. Now this profile is going to be extruded the entire height of 50. And again, it thinks it's cutting out from the other object. So we'll put that back to join. There's our basic shape. Now we're going to do a couple of things. We need to round this off with a radius of 2, as per this. So this is where we start getting into these modify tools. And what do you know, there's a fillet. Fillet tool to round things off. So push the dialog out of the way and grab the object first. And then one of the other convenient things, we're sitting in hovering over this input, and I can click on the input. Oh, I'm not doing it now. Well, anyway, it's a radius of 20, which is our version of 2. So there's our radius, nice and convenient. Now we got to locate a couple of holes. So what kind of holes are these anyway? Let me just say 2 drill, 2 holes. So not terribly high tolerance holes. Nothing particularly special about the shape. But we do sort of need to locate their center points, and we don't have anything to locate the center point yet. So let's draw another sketch. We're going to draw it right on this plane, and we're going to sketch out where our holes should be. So we're going to essentially just need 3 lines. Yeah, 3 lines. 2 lines for the horizontal centers, and 1 line for the vertical centers. Now, we're not going to do anything with these lines in the sense that we want to create a profile. So one way to make sure that they don't interfere with what's considered a solid profile is to turn them into not a solid line by making them a construction line. So here's that top option to turn them into construction lines. They become little dash lines instead. But we still need to put in the proper dimensions. So it was 2 from this edge to that center line. And in our world, that's 20 centimeters, or 20 millimeters. And then the next dimension was 3 from that offset. Or 3 from that center line, or rather the center lines are 3 units apart, which they already are. How convenient. Now this bottom line is, what is this? Does that look like a 3 to you? Looks kind of like a 3 to me. We'll go with it. Gotta accept that one first. So here to there, and it's already 30. How convenient. See, it helps to have a grid set up in the units you need to be working with. So now we've located these center lines, these intersections. That's where our holes are going to be drilled. So now we can finish our sketch. Take a look at it this way. Time to drill some holes. Now there's conveniently a hole function, which saves you the time of having to draw on your sketch a circle and extrude the circle. Instead, you can pick various types of holes, like a simple straight-through hole, or one meant for a counterboard for a screw, or countersunk for a screw, and all this kind of thing. And whether it's going to be tapped and drilled and so forth. But pretty much we just need a simple straight-through hole. And we want it to go all the way through the object that we give it to. And then we don't need a pointed drill point, we'll give it a flat drill point. So all of those features are designed for in different machine screws and the like. We're going to make a really simple one. So we're going to lean on the button. I forgot. I hate when I forget a step. So back here in the sketch, we created the crossed lines, correct? But instead of having the intersection, I'm looking to, where'd it go? So last time, I'm always on the wrong screen lately. Okay, so something's not behaving the way it was before. Before, I was able to just click on the two lines and pick the intersecting point. Let's see, why is that not behaving? Nope. Is that because they're construction lines? That'd be kind of annoying. Well, let's go see. Let's not make them construction lines. Let's go see if that has the effect I'm looking for, or used to, I should say. Yeah, see how those introduce the dot?
Yeah.
That is the intersection. So back to the hole command. We pretty much had it. Base and sketch points. Oop. Seems a bit big.
Especially to put the next one next to it, yes.
What was the size of it? 2 holes, 2 drill, 2 holes. Does that mean that they were 2? Does that mean they were 2 in size? Because they're certainly not 30 millimeter. Let's see. That should mean that they're 20 millimeter. Alright, that's probably more like it.
Yeah.
There's our hole now.
Both of them. Yeah.
Now, I don't think the hole is properly located.
That one is. I think the other one will be too.
I'm not sure, but conveniently we can just open up the hole itself. Or the properties of it, I should say. And yeah, apparently... So yeah, it's not quite centered. And I thought... This is something new on me here. Let's cancel that. And let's go back into our sketch.
There's no intersection.
Why are you not intersecting? What am I doing wrong here? Oh, there's hole, conveniently. But I don't know.
There won't.
Huh. Oh, so you're not seeing it in the tool here. That's what I'm missing. So this is the downside to the hole, right? Because the other alternative to using the hole command, and it would be easier on this one anyway. So we're going to do this way. We're going to do one hole using the normal sort of what we're used to, and the other one using the hole command. So to do that, we're going to go back and oh, I'm still editing the sketch. I thought I had saved it out. So in order to use the hole command, we need that hole, that point, right? So we select the point, and we say we want it a point. We want it to be a point. Now the other one is this intersection, and while we're sketching, you can see it likes to snap to the intersection. So we're going to do this one the other way by drawing a circle to being 20. And now we can finish our sketch. Let's take this hole. There we go. And move it over here until it actually snaps to that point that we put in the object. You'll actually see it says what face you want to attach it to, missing face or points. So here we can select the face and selected the point at the same time. So that's how we get a hole in the right spot using the hole command. And it's convenient if you needed it to be countersunk for a screw or something like that. But if you're looking for something more straightforward, you can just extrude these 4 little pie wedges. Now again, here, I'll show you why this is why you want those lines to be some days I get lost in the cube. So come back to the front here. Go home, that's the one. There we go. All right. So because these lines were solid lines instead of construction lines, they actually create separate profile sections. And we don't want them to, because we want to only do one extrude and sort of keep it simple. So if we make them back to being construction lines like we did before, our hole is still there because the point was still drawn. Now, though, when we highlight this profile, it's just the hole. It's not the individual pie sections. So again, you can do the old extrude. We're going to specifically say cut. We want it to go backwards. I guess we can probably say through all. That will do it. There we go. That looks pretty much like it. Let's bring open the original. That should look like it. We actually had a dimension drawing to go off of this time. So again, let's hide all the sketches. Now, one other thing we can do is compare our drawing. There's our front side view. There's our front side view in the 3D object. It pretty much matches our front side view here. Correct? Looks about right. Now, if we want to look at the right side view, that's not quite the same. And it's missing these hidden lines. And that actually is a part of this menu down here where you can say that your move that out of the way. So we want to go to down here and we want to say our visual style would be to shaded, but with the hidden edges. Why is it not clicking? What are you doing to me, Fusion? Come on now. So one of the downsides to Fusion, and this is really common, it's an upside and a downside. It's a cloud-based tool. So it means that it's constantly talking back to the main server. And sometimes you end up with these delays and sort of odd effects. Because that should not be shaded with hidden edges. That's not what that would be. Oh, there we go. Interesting. It's not showing the edges of the circle. Like it's showing the far hidden edges of the outside, right? And the far hidden edges of the hole in the circles, but it's not showing if you go to the right side view, it doesn't show the hidden lines here. That's probably in the other feature. We'll have to look at that later. Here under the design feature, you have a whole lot of capability in Fusion, and there's a whole separate section about drawing from a given design, and I'll have to get into that much later. And that's where you take a 3D object that you've already built, and you create these 3D views that would be used for manufacturing versus 3D printing. But luckily, all we have to do for 3D printing is save these out and print them. So hopefully next time we'll have all these printed. I think we only got through, what, 3 of them? That's okay. That's a good start.
Awesome.
So next time we will get, let's see if we can show them all at the same time, but they're kind of overlapping. So that's not particularly useful. So in any case, we can also show this kind of like a drawing at this point. We can say a wireframe with visible edges only. And that kind of looks like the drawing, a line drawing. But there's a whole separate module for drawing and creating dimension drawings. So we'll get back into that next time. We've managed to make 3. Hopefully we'll have these all printed and we'll show them to you. So I hope you had a good time. If you showed up for a brief time, I'm not sure who all came in and out. But if you like it, go ahead and like it. Let us know. Give us comments. What do you want to see next? Like I said, we're trying to keep this at the super intro level because that's what these documents are. They were my very first assignments going into drafting or technical drawing. So anyway, thanks for watching. We'll see y'all next time. And I am off and away.